this function will be called when your program starts. So if you need to initialize something, you should put it here. Okay? Then there's a function called update. This one will run as many times a second as your computer will allow it to. Right? So it just keeps updating. And we have another function called draw. And this one just draws whatever you want. You can actually take all the code from update and put it into draw, because draw is also called again and again. Yes?
File did you use?
Test app CPP.
Yeah, but it's called that inside every one from the...
What example?
What file? What project did you open?
I made a new one called slideshow.
It's not one example, it's something we
No, I took the image loader,
Thank you.
copied that one, and then I stole a little bit from the movie grabber example. Just because I'm lazy. Okay? Now, when you have multiple functions like this, how do you make sure they can see the same variables? Please somebody say global variable.
Global variable.
No, you do not do that. Well, yeah. What is happening is we have a class over here called test app, and all these functions belong to this. So it can of course see what's inside this class. That's the way it's made in Open Frameworks. So, in the header file, test app header, if you need a new variable that all the functions should be able to see, you create it here. This is images, and this is some other data. These I made for the example, right? So declare them in the header file, and then you can use them everywhere here. So declare them over there, give them a value in the setup, and then we're ready to go. Right? Then update can also read them and draw. If you like to control something, as I showed you before, you can just make a switch case in here. And if you press a key, then key will have the value of the one you just pressed. So if you make a switch case and you check for the char called A, for example, you don't need to press A and enter, you just need to press A, and it'll do whatever code you put in here, right? Make sense? So we could make a little switch case in here, so you can go back and forth in the alpha blend, so we can fade back and forth between two images if we want to. Okay? Cool. Or so you start it here and you can pause it or whatever. Yeah? We'll come back to this. Cool. So, in my header file, since I copy-pasted the code, I should actually delete this thing. So, we would like to use 4 images. Right? And I call them Carter, Babe, Sketch. Right? Because that's so I know which one is what. I'm only doing it this way because I have so few images. If I had a lot of images, I might do it in a different way. So I might make some code that could automatically load in every image from a folder. Or I would name the images 1, 2, 3, 4 and change the code, so I just have for loop that loads everyone in. Right? And copies in. I actually only need one image. I can load an image into that one, copy it over to my data, load it into the same image, copy it over, load it into the same image. You understand? I don't need 4 images, I just need one. But since I only had 4 images, this was the easy way to do it. Right? The simple way. And even when I program, I try to normally get something up and running the simple way first. If it's running, it's compiling, it works, then I'll try to make it more advanced. If you try to program something highly advanced to begin with, and then it doesn't work, good, where's the bug? Right? Always try to keep it simple first and then expand on it. It's much better. Cool? So, we load in 4 images, and I named the images the same as I named my variables. It's really easy to find out. And then we create this data. Now, this lovely little data is a pointer, and you don't know what pointers is yet. So, data is just one variable that has an address to a whole chunk of data, right? So, when I add new, I will dynamically get a piece of memory with some unsigned char in it. We'll come back to this in pointers and programming, right? So I have a lot of data lying in memory now, and data points to where that is. That's all you need to know about pointers, okay? So data is now my handle to some memory, okay? Cool. Pics. Pics is my little super array I made over here. So pics can have 8 pictures. We only need 4 for this. So, yeah. And into these, I ask get pixels. This is a function that will also return a pointer. Pix is also a pointer of type unsigned char. So each variable in pix, we have 4 of these, will point to a different image somewhere in memory. Okay? Don't get confused about pointers yet. I hope you can do it anyway. Cool. I then use get pics, so I get all the values from my picture called I into the first one called 0, and everything from the Carter into 1, the babe into 2, and the sketch into 3. Right? Cool. I create then a texture. I have it over here. OF texture. Cool. And then we allocate some space for that. 600 times 400, and we would like it to have RGB. So it's not grayscale, it's color. And then I just made 2 simple counters. They're just integers. Also, of course, I have to declare them here. Oh no, let's see, that's actually a float. So this one's an integer. Yeah? Cool. In the update, we update our counter. It's a little bit more advanced because I'm using cosinus. So, what I will try to do now is try to change this code into the simple one we had on the blackboard, right? So from my really complicated advanced one into something simple. Cool? Good. Now, I need my slideshow to loop, right? I have 4 images and I would like it to loop. So even as the counter pix keeps going up, I would like to keep looping between the first 4. So how do I do that in an easy way? I use modulus 4, right? So if the counter keeps going up, then it'll be 0, 1, 2, 3. As soon as it gets 4, modulus 4, it becomes 0 again, right? 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So even pix counts from 0 and up to an infinity or a billion or whatever. If I take pic modulus 4, it says 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Does that make sense?
Yeah.
Cool. So I have, this will give me 1 picture. And then I say picture plus 1 modulus 4. So if 1 is 0, the other one's 1. And then I just go like this, right? Well, that's really hard to do. Okay, you get it. Good. So we're always fading into the next image. So if we add image number 4, which will have number 3 in the index, then the other one will be 0, right? So from the last to the first. Okay. Cool. Now, let's make it easy way. We just multiply by alpha, right? And over here, it's 1 minus alpha. I should do like this. Cool. Can we agree this is more or less the function we have on the blackboard? What do you say? Is that okay? This is my x. This is my x1. And this is my x2. Okay? No comments. Are you following me, or are you sleeping, or is it okay?
Yeah.
Please stop me if you need me to explain something, because if I leave you behind, there's no point. I can just go for lunch. Right? I'm here to try to help you, so give me some feedback if you want me to explain something in more depth. Cool. Now, I makes me run through all my data. As I mentioned the first day, when we talked about it, no, not the first day, but the first time we talked about arrays. Remember I said this, we play with 2D arrays, images are 2D arrays. But OpenCV, Open Frameworks, they just store data using a pointer somewhere in space. So you just have all your 3D images, or 2D images, as one-dimensional. So the way it's stored is just the first row like this, and then after that the next row, and after that the next row, after that the next row. So the images when you play here are one-dimensional. Don't worry, for this exercise you don't need to worry about dimensions. But total pixels is the width times the height times the number of colors. So all information is stored in one long row. Not in nice 3D as we would like to have it, right? But in one long one. Does that make sense? So the first thing I have is my first pixel, red value, then blue, then green. Next pixel, red, blue, green, red, blue. Red, green, blue, red, green, blue, red, green, blue. Actually in OpenCV it used to be backwards, really confusing. So total pixels is 600 times 400 times the number of colors. And we just run through the entire array of the first one, all 3 dimensions, using just I, but it's the same I we have over here, and we also use it over here, so it's fine, it copies. You don't have to think about dimensions now. If I had to transform, take a part of my image and copy it somewhere else in my image, or I have to mirror it, then we need the coordinates. But for this we don't, right? These numbers are always the same, and that's all we need. Yeah? So I have a 2-dimensional image, a 2-dimensional array. First one gives me what picture I want, and the other one holds all the data for that picture. Okay? Cool. And data is something else we use so we can load data back into our texture. Right? That could also have been something we'll pick, but it's the data we work with. This is our output. Cool? Good. OF background just sets the background color to white. In this case, we could also set it to black. How do we do that? Any guesses? Good. What if I want it to be red? Right? Red, green, blue. So now it's red. Yeah. It's a built-in function. That one you're allowed to use. But else, not allowed to use hand-in built-in functions for your hand-in. You have to program it yourself. I don't want you to just find a function in Open Frameworks that says alpha blend from one image to another and call that one. That would be cheating. But for a project, I recommend you do it. Okay? Cool. And after doing this, we will load the data into texture, and then down here we'll draw the texture. Okay. So now we have to do it linearly. Should we use our nice little counter here or what? Cool. So, if our counter gets how big?
1. Sure.
Good. If it gets bigger than 1, then it should go back to 0, right? Oopsie. And we want the next image. That's simple, right? Cool. Do we really need counter? We just need alpha, right? Alpha is our counter. And this is how fast it should blend from one to the other one. Really quiet. So I'm going to delete this cosinus down here. And it's only alpha we play with, so I can actually use modulus. No, never mind. Okay. So like this, alpha keeps growing from 0. If it gets bigger than 1, then it'll go back to 0. And we start the next image. Do you agree? Cool. And I don't know if I missed anything. Let's just try to run it and see if it gives me a bug. It works.
It's a power.
Do we think it goes a little bit too fast?
Yeah.
By the way, do you like the red background we just made?
No.
It's beautiful.
Yeah, half empty people. Yeah. So this is how fast it grows. So if I add less value to this, it should be much slower. Now you can also use a function that looks at how much time has gone between each update. That's the right way of doing it.
It
What?
was jumping.
It's jumping.
Yeah.
Oh. Why is it jumping?
Pictures jumping.
Why is it jumping, guys?
Cool.
No.
It reaches one, it takes another, or loads a second picture.
Doesn't matter this.
It fades from picture number 1 down to 0, and then it wants to jump. So it fades from 2 down to 1, and then from 3 down to 2. That's the wrong way to go. So we'll just flip them. It's because I use cosinus. So just flip them. So we go from this one, from pick to pick plus 1, right? I can also change the alpha here. So if I do it now, it works, right?
Yeah.
But have you noticed we don't have a break? It goes directly to the next, to the next, to the next. Yes? Okay. How can we make it stop doing that?
I pause the update.
We don't want to pause the update. We want to make sure that it doesn't continue. How can we do that?
And it takes a break, or that it doesn't continue
It doesn't continue on the next transition.
until you press the key or something.
No, we just wait another
Oh,
second.
it
or-
should just take it. Yeah.
How can we do that in an easy way? Yeah?
You make it that it goes more than one, so that it's after it's already loaded, the picture fully continues up a bit more than until it changes to
Okay.
the next picture.
That's a cool way of doing it. So, we will let it run up to 2, for example. Right? But, then we would only update if it's smaller than 1. Right? Only if it's smaller than 1 will we actually update it. So that means it runs a transition from 0 up to 1, where it's changing our image, and then it stops, and then it continues up to 2, then it flips the images, and then it starts again. Right? We can even make that longer and into 3, for example. Then I'll speed this up a bit. Like this. Okay? Fast transition, it stays, and it stays. Okay, I'll make it stay a little longer. Zoom, fast transition, and it stays. Not transition, and it stays. Right? That's an easy way. But right now we're only doing one transition, right?
Yeah.
Yeah? So we should have multiple transitions. Agreed? Cool. How do we do that? Yeah?
Put them in an array that runs one after the other.
Yeah. Or you can make like a switch case. So for image, if it's image 1 I'm at, I'm going to transition like this, for 2 like this, for 3 like this. It's just an easy way for you to do it. So if I build a switch case around this code here, and then only if picture is 1 am I actually blending like this. For picture 2 I'm going to blend in another way, and for picture 3 in another way. Does this make sense? Yeah?
Yeah.
but this is a simple linear interpolation. Do you think you can do this at home?
Try.
No?
Maybe.
This is not much code. I'll remove this because it actually belongs up here. Do you think this is too much? You cannot do this.
It's more like the code from the image example you
What?
need to.
This?
It's just how you're going to implement it correctly, so it doesn't fuck up the other.
The only thing I haven't drawn is this. Okay, this set color, don't mess with it, but you can see what I do if I do this. No, but it's kind of like how much light we want. So just leave it alone. Now everything's just dark.
Yeah.
Right? So it's kind of like being multiplied to everything. So just leave it at 255. Do you have any questions?
Yes.
Yeah?
You also have to explain the code in the ending or
Yes. All the interesting piece of code. Do you need to explain all these functions that has nothing in them? No. And do I need to explain everything else I'm not using? No.
do you want it in the same ending as the slideshow?
Yeah, just make the slideshow run and then stop it and then explain the code in one video. Boom, right? So all you need to do is saying, so here I'm loading in images, I made them over here. These are of type of image, which is a built-in type. And so I'm using the load image function to load in these images. Boom, boom. Then I have created a blah, blah, blah over here. Right?
What kind of image formats works with open source? Only PNG?
No. GIF, PNG, JPEG, bitmap, TIFF. You can read a lot of stuff. Right? No, but all these, you know these, right? You don't know TIFF or bitmap. Okay, very fast about image formats. So, if you want to save some memory, a bitmap image is close to what we call raw data. So it's really not compressed much. So it takes up a lot of space, but it has very nice colors and everything. And it's really sharp, really nice. And then you can use something like PNG or GIF, where you can actually compress the colors, if you want to, down to only 8 bits instead of 24 bits. So you compress the amount of data to a third, just instantly. It's very, not often you can see the difference, unless you really have a nice, cool picture with some nice colors. There's another way of going. If you take photographies, and you can see most of these images are something like photography, right? So for the sketch, it would be bad to use JPEG, even though I did. But for the other ones, like the eye and the guy sitting there and stuff like this, who looks like an image, it's very nice to use JPEG. JPEG is a very advanced image format, and it tries to remove all the details you cannot see anyway. We will come back to how JPEG works. But JPEG is a good format for something that looks like an image, right? So it compresses quite a lot, but without humans being able to see it. If you compress it really a lot, you can see that everywhere where there's a rapid change, you get some noise, right? Okay. Use any format you like, and you can read a lot of different formats, or else you can just use something like Photoshop to convert them, right? If you have it in some weird format and it doesn't work. I just took some images and I put them into the image folder. In your example, there's one called bin data image in your image loader. Put them in there, and then it will automatically read them like this. Right? Okay. I will help you a little bit on Facebook, just a little bit. But please try to help each other out. Next Thursday, I have in 2 days. I have 2 TAs to come here just to help you set it up, and you might have them help you with making this too. Right? So if you don't have Open Frameworks working, make sure you're here early Thursday. Because if you don't have Open Frameworks working and you don't have OpenCV working or anything like that, programming this slideshow can be pretty hard, right? You do not want to do that from scratch, building your own library, right? Well, you could even cheat and install OpenGL and then go that way.
Yeah.
It can also show a 2D image. But the easy way is Open Frameworks. Yeah? So please make sure that's the first thing you do when you get home today. Make that sheet work. Agreed? Cool. Let's go and have lunch. I hope you can still beat the human at the canteen.